Hey, my name is Steven, and I'm going to show you how to set up your LumenPnP for its first job. This is the board we'll be making today. It has 11 unique components ranging from small chip resistors all the way up to a large wireless module. For extra information about getting your LumenPnP set up for production, you can go to docs.opula.io. And if you have any questions, you can always send us an email at support@opula.io. The first step is identifying how many unique components your board has and what tape width they come in. This board has 6 parts that come in 8mm tape, 2 that come in 12mm tape, 2 that come in 16mm tape, and 1 that comes in 44mm tape. The LumenPnP has powered feeders for 8mm tape and 12mm tape, and we also have strip feeders for every standard tape width available for sale on our website or downloadable for you to 3D print yourself. We'll use powered feeders for the 8 and 12mm tape, a strip feeder for the 2 16mm parts, and 1 adjustable feeder for the 44mm tape. Now that we know which feeders are required for our job, we can mount them and our PCB to the LumenPnP. I've gotten my design panelized by the board shop, which makes assembly much more automated, but any board will do. By default, the LumenPnP comes with 2 staging plates. This should be enough for my job, but extra plates are available at opula.io if you need more space for your panel or more strip feeders. Note that adding the 3rd staging plate limits your total powered feeder count to only 25 instead of the full 50 when you're only using 2 staging plates. I think my strip feeders will fit here and my panel will fit here. Now that I've selected my layout, I'm going to remove all power from the LumenPnP. I'm going to gently move the head back to the back right corner of the machine, and then I'm going to lift it back up onto its back legs. This is a great way to access the bottom of your machine for strip feeder and panel mounting. Next, I'll mount the strip feeders using the included hardware. It can be helpful to check that the tape is able to be pulled through the strip feeder cleanly, and also that any inline feeders are aligned correctly. Next, I'll mount the panel. This can be done using the universal board mounting hardware that comes with the LumenPnP. This is the static board mount, which helps hold the panel in place either along a flat edge or a corner. This is the dynamic board mount, which helps apply a little pressure to the panel to hold it in place. And these are the board supports, which help support the panel. When mounting the dynamic board mount, make sure that the edge of your panel lines up with the mark on the top part of the hinge, and this will make sure that the dynamic board mount will apply the appropriate amount of pressure onto your panel and holding it tightly in place. Now I'll check to make sure that it holds my panel in place nice and tightly, and it's also easy to remove. Where you actually mount these features depends greatly on the size and shape of your board, but they've been designed to be adaptable to pretty much any size and shape PCB. Once everything is mounted and secure, I'm going to bring the machine back down onto its 4 legs. Now I'll load up all my powered feeders and load tape into all of them. There's full instructions how to do this on our docs page, including a demo video. And finally, I'm going to load all of my tape into the strip feeders. It's best practice to only remove the film holding the parts in right before you're about to run the job to make sure that all the parts stay in place during setup. When doing setup and cal for a certain board type, it can be helpful to not quite use solder paste yet. A really handy trick is to use some double-sided tape, which came included in your LumenPnP kit. Using a little bit of double-sided tape on your PCB allows you to test place parts and check for accuracy and calibration without committing to actually putting solder paste and getting it all over the place. This is what I've done here on just one of the boards in my glow tie panel, and once I'm confident that everything's set up correctly, I'll switch over to actually pasting my boards. Now I'll plug power into my LumenPnP and connect it to my computer using the 3 USB connections, 2 for the cameras and 1 for the machine control. Next, I'll run OpenPnP. Make sure that you're using the version of OpenPnP recommended in the docs page to ensure that it can communicate properly with the feeders. Now that I've opened OpenPnP, it's time to connect to my machine. To start, I'm going to go to Machine Setup, click the drop down next to Drivers, and then click on G-Code Driver. In the Configuration tab, I can look at the port, and I can select the port for my machine, and then hit Apply. Now I can press the power button in the bottom left of the UI. And once the button turns red and you get a yellow house icon, that means that you are connected to your machine. Next, we're going to connect to the cameras. The bottom camera can be found in the dropdown under Cameras. If you click OpenPnP Captured Camera Bottom and then go to Device Settings, you can pick the camera from this device dropdown. For the bottom camera, you're going to want to select PnP Bottom Camera and make sure that your format is set to a 1280 by 720 at 10 FPS and hit Apply. This is also the same menu where you can adjust exposure and contrast and all kinds of other settings. Under Heads, Reference Head, Cameras, you'll find OpenPnP Capture Camera Top. Do the same thing for this one under Device Settings and make sure that you selected PnP Top Camera and you selected the format to 1280 by 720 at 10 FPS. And then hit Apply. Now we're going to try and home. Homing on the LumenPnP requires some vision. When you home your LumenPnP, the head will move to the front left corner of the machine, and then it'll jog the camera over to the homing fiducial. Then it will find out where this homing fiducial is in space using a little bit of machine vision. and then it will do a nozzle tip calibration on the nozzle tip. This happens every time that you hit home, and it does a calibration on where the head is in space and where the nozzle tip is and how it rotates. If this is your first time setting up the LumenPnP, make sure to check out our other video about setting up calibration from the beginning. Now that we're connected and homed up with our machine, it's time to export the position file from our ECAD software. I use KiCad to design this PCB, but there's a similar process for Altium and Eagle and every other major ECAD software. I'm going to go to File, Fabrication Outputs, and select Component Placement.pos file. You can select ASCII. Make sure that your units are in millimeters and separate your files for your front and back of the board. My board only has SMT components on the front, so it doesn't really matter for me, but it's good to keep them separate. Pick your directory and go ahead and click Generate Position File. This is all you need to tell OpenPnP where all the components are and what kind of components they are. Back in OpenPnP, we're going to go to the Boards tab, press the plus button, and say Create New Board. And here I'm going to pick the directory where I want to create a new board, and I'm going to call this glowtie.board.xml. This is the format that OpenPnP saves a board in. Now that I've created this new board, it's time to import the position file that we just exported from our ECAD. To do this, we're going to go to File, Import Placements, KiCad.pos file, and now OpenPnP gives me a place to select my position file. Select the position file, hit Open. I don't have a bottom position file, so I'm not going to put anything in there. And under Options, I'm going to select Assign Parts and Create Missing Parts, because I don't have some of the parts in my parts library in OpenPnP that are in this board, so I want OpenPnP to make them all for me. I am not going to select Use Only Value as Part ID, and then hit Import. Now that all the parts have been populated into the board, we're going to go into Job, hit the plus button, select Existing Board, and we're going to pick the board that we just made. And here we go. We have one board now in our job, and we can see here, these are all the placements that we have in the job. The first thing to do when you get all these placements in is to see if there's some of these things that actually don't need to be placed. For example, this here is a footprint for the logo on the PCB, and this isn't actually anything that needs to be placed, so I'm going to uncheck the enabled column for this component. All the rest of these are valid parts that need to be placed. The other thing to check for are fiducials on your board. If I scroll down, I'll find 3 fiducials here. The way to actually tell OpenPnP that these components here, these placements, are really fiducials, and to use them for locating the board in space, you can go over to the type, and instead of placement, you can select fiducial. You can do these for any fiducial that you have in your board. So now we need to tell OpenPnP where to actually find the board. In the board table up here in the top of the Jobs tab, these positions are just where the 0 point in your ECAD is, so this number isn't really that helpful for finding where your board is in space, depending on where you designed your PCB in your ECAD relative to the 0 position. What I usually do to start to find my board position is I'll put in a large number like 300 millimeters into X and Y, just to move the head to at least kind of close to where the board is. And I'm also going to put in -90 for the rotation, because that's how I know I've rotated the board in the area of the LumenPnP relative to how I designed it in KiCad. Now I'm going to find a placement that is recognizable from the top camera. So I'm going to pick my switch right here, SW1, and I'm going to jog the camera to where OpenPnP thinks that position is. Now, this is obviously wrong. This is not at all where it is, but that's totally okay. We're going to use this to find out where the board actually is. In the bottom right-hand corner of the OpenPnP UI, you'll find a green DRO, or digital readout, which tells you where OpenPnP knows the machine to be in space right now, its coordinates. If you click it once, it'll turn blue and 0 out, and now OpenPnP is in measurement mode, so it'll measure how far you've moved. Now what we can do is we can jog the head around to actually where switch 1's footprint is. So I'm going to do that now. And as I do this, you can see it's keeping track of my movement, so we can find out actually how much we need to offset this board's X and Y position to make its positions accurate. Beautiful, that's perfect. It doesn't have to be exact, it just has to be close enough for OpenPnP to find your fiducials. So I can see here I've moved in the X positive 35 millimeters and in the Y 51. So I'm just going to apply these numbers to my X and Y coordinates for the board. And now if I try and jog to my switch position, of course it's in the exact same position, but if I jog to the next footprint, I'll find that I'm pretty darn close to the positions of all of these components. It's not accurate, it's just kind of close, and that's exactly what we want. The fiducials are used for getting really accurate positioning. Wonderful. That is exactly what I want to see. The next thing we need to do is set the board's Z height. Now that we have its X and Y position set, we have to make sure that the nozzle is actually going to come down to the correct height to place the part. To do this, I'm going to pick a certain component, doesn't really matter which one, and I'm going to click this button, which will move the nozzle tip to that placement's location. And now I'm going to jog a a nozzle tip down. Just make sure you have the right one selected under machine controls here. I'm going to use N1 for this. And then I'm going to jog the Z down until I see the nozzle tip just barely touching my PCB. And there it is. It just touched. So my Z position is going to be, I can check here in my DRO in the bottom, I'm at negative 27 millimeters. So that's what I'm going to put into my Z. That's where my board is, negative 27. Next, we're going to try a fiducial calibration. We have our fiducials all selected, and we have our position set accurately. Now, if we click this button up here in the top bar, it'll perform a fiducial check for the board that we have selected, and we'll see how well it works. Here it is finding the fiducial on the board. You can see it finding that red circle and finding exactly where that fiducial is in space. It's good to have at least 3 on your board. That's what I'll use for all of my designs, is at least 3 fiducials. And here it is finding the 3rd one. So now we can go ahead and move our camera to all of these placement positions and see how much more accurate it is. See how that is perfectly in the center of the placement? This is after we do our fiducial cal, we get much more accurate placement location. And these are all dead on perfect in the center of the board. That's exactly what we want to see. Now, before we go in and set up our feeders, we need to tell LumenPnP a little bit about which nozzle tip to use for which part. The way we're going to do this is going to the Packages tab along the top, and for each one of these different packages, we're going to select under the Nozzle Tips option which nozzle tip is compatible to pick this part. This might be something that you want to tweak over time if you find that some parts do what's called pirouetting a little bit on the tip of the nozzle. If the suction isn't quite enough to hold that part onto the nozzle tip, if you move up to a bigger nozzle tip size, larger in diameter, it'll pull with more force, and you'll be able to pick your part more consistently and with greater strength so that it's not moving around on the tip. In general, you should be able to populate almost every kind of component using just 2 nozzle tips, the N045 and the N24. If you put the N045 on nozzle 1 and the N24 on nozzle 2, you can populate a vast majority of components on a wide range of boards without needing to do a nozzle tip swap. So that's exactly what I have set up on my machine. I have the N045 in the N1 slot and N24 in the N2 slot. So I'm going to go down through all these packages and select either N045 or N24. Things like fiducials don't need a nozzle tip, so don't worry about adding a compatible nozzle tip to them. The LumenPnP is capable of picking up parts as heavy as 25 grams, which is actually an entire Arduino Uno. You need to use the N75 nozzle tip with the largest diameter for this, but you can pick up some very large components with the LumenPnP. Now that we know that our board is in the correct place, it's time to figure out where our feeders are and make sure they're all configured correctly for the job. The first thing we're going to do is scan for the LumenPnP feeders. Under the Feeders tab, you'll see we currently don't have any feeders configured in OPNP, so we're going to hit the plus button, and we're going to scroll down to Photon Feeder. Photon is the name of the firmware and the protocol that controls the LumenPnP feeders. So then we're going to go ahead and hit Accept. And we'll see in the Global Config tab, there's a search button. This search button will look all the way through all the addresses up to 50 and see if there is a Photon feeder present. So we're going to go ahead and hit Search. And we can see those green ones are actually found feeders, and there are all the feeders we have mounted to the machine. So now what we can do is go and find the pick position for all of these feeders, and also put the appropriate part in them based on all the parts that OpenPnP has imported from our board. A really easy way to find out which feeder is which is to just grab a random position in the slot location, hit Apply, and then hit Feed. And that will move forward 4 millimeters or whatever pitch you put in here on the feeder. It's a really good way to just check which feeder you have selected here. If you want to rename your feeder, you can go up to the top here. Don't worry about deleting the slot number. It'll automatically re-add it afterwards. And I'm just going to put WS2812 in here because that is the name of the chip in this feeder. And it'll automatically re-add slot 12 after that. And now it's time to go and find the pick position for this part. I'm also going to adjust the part in this feeder to be the actual part that it has, which is LED WS2812. So that's that. I'm going to hit up. Now we need to actually set the pick position for this feeder. Based on whichever nozzle tip we selected for the specific package for this part that's loaded into this feeder, I'm going to use that nozzle tip, N2 right here for this LED, to set the position. So now I'm going to jog my head over to this feeder, and I'm going to slowly bring the head down until it's perfectly centered over the part. Now, if this is the first time you've booted up your feeders, it's good to press the forward button once to make sure that The tape position is where it's going to be consistently every time. On boot, the first index is going to move to a slightly different position, so it's good to just hit forward once just to make sure that that's the consistent position you'll be picking from for the entirety of the job. So I'm going to do that. I'm just going to tap the forward button, and now my part is forward, and I'm going to bring the nozzle tip down into it. And right before I get there, I'm going to turn on the pump, and then I'm going to slowly bring it down 100 microns at a time. As soon as I see the part pop up to the nozzle tip when the suction has grabbed the part, I'm going to bring it down another 100 to 200 microns from there to really ensure we're picking the part properly, and that's a really good Z height to set the pick position. You also want to set the pick position to be as close to the center of the void in the tape as possible, not so much about the part. The part can wobble around inside of the void in the tape, so you really want to center the nozzle tip in the void in the tape as opposed to where that specific part happens to be. I'm going to turn on my pump, bring it down until I see it connect, bring it down another 100 microns, and then capture that position. Here we go. Now my pump is on. I'm going to jog it down a little bit at a time. And there we go, we got it. So I'm going to bring it down a little bit here, and that's a pretty good pick position. So I'm going to capture this position here, and I'm actually just going to capture the same one here for part offset as well. Now I can turn off my pump, and it'll let the part go. And then I can jog the head back up, get it out of the way. We also need to set the part pitch. So this part actually has 2 pips or 8 millimeters that it needs to move for every component. So I'm going to set 4 up to 8. This unit is in millimeters. Now we can test the pick operation for this feeder type. So now if I click this button up top while this feeder is selected, it will feed the feeder and then pick it. So let's test that and see how that works. Cool, so we've picked the part. Now, if I want to see how the bottom camera will find the vision for this part, I can go to Parts and select the part that I just picked here, which is my WS2812 LED, and these are my bottom vision settings under this tab. So this is generalized bottom vision. If I want to specify my bottom vision for this part specifically, I can click Specialized for LED WS2812, and then that will make any settings I make on this part now specifically just for this part, and it won't edit the general bottom vision. It's generally good to do this for anything that isn't like an 0805 resistor or something pretty generic. I like to specialize if it's something kind of outside of the ordinary, makes it easier. And now I'll hit test alignment and it will bring the part over the bottom camera, and it will try and find out where the part is, find the boundaries of it using bottom vision. So there it is, and it actually found it really well. There is our part right in the center. It was able to identify it wonderfully. And if I need to edit this pipeline at all, I can just hit edit. And now I'm going to discard the part now that we've done vision for it. So now we go through the process of doing all the rest of these feeders, putting the appropriate part in there, putting the part pitch in, and then finding the pick position down here, and then test picking a part, and then discarding it after we know that it works properly and that our bottom vision is able to appropriately discover where that part is in space. Now that everything is set up for my job, I'm going to go ahead and click the play button and watch the Lumen populate all the parts onto my board. So after your job is done, you can go and see what settings need to be tweaked, especially for placements and rotations of parts onto your board. What I will usually do for this is I will go through a board and I'll look at every single placement and see if it was offset a little bit or if the rotation is wrong, and then I can go and make a calibration from there. So it looks like a lot of my passives are shifted just a little bit to the right. It looks like my micro USB connector is rotated 90 degrees, negative 90 from where I want it. So I need to go into my feeder for that, find USB, and I'm going to change that rotation to 90 degrees to make sure that that lines up with how I want it. It should be facing to the left. LEDs are actually rotated 180 degrees, so I can go and change the rotation of that feeder to be 180. And also it looks like larger parts are offset a little to the right as well. So I probably want to do Tweak my top camera to nozzle tip offset a little bit. Yeah, definitely shifted a little bit on my passives. Fiducials are dead on. Switch looks good, correct orientation, placed well. Looks like my LiPo battery charger is placed 180 degrees backwards, so I need to go and flip the rotation of that and its feeder 180 degrees. And same thing with my LDO, that also needs to be rotated 180 degrees. So I'm gonna go and change those in those feeders. All right, so now I have 180 degrees in for my LiPo battery charger and my LDO. So this should be much better. Now I'm going to do a top camera to nozzle tip offset calibration to make sure that the offset between the top camera and the nozzle tips is exactly what it is on the machine. That's going to make my placement much better. You can see instructions for how to do this on our website and also in our calibration video. All right, so I have just rerun the job after doing all of the calibration, and now we're going to see how accurately I place parts this time around. But all those WS2812s are dead on as well. Redoing that cal definitely helped. Much better. Much better. Great. These look fantastic. So now that we have a successfully placed board on double-sided tape, we can go ahead and start stenciling solder paste onto our boards, multiplying out these boards if need be, adding extra existing boards if I have a whole panel. You can just go ahead and add a whole other one, and then do the same procedure for setting the position as you did for the first one. You can alternatively use the Panels tab to make a whole panel and give LumenPnP the understanding that there's an entire panel of boards attached to each other. And paste up your panel and start running some boards for production.